Hi, Mr. Wright here, and welcome to this film in which I'll walk you through the solutions to the first 10 of my 50 grade 8 and 9 IGCSE exam questions. This film is perfect for you if you are aiming for a grade 8 or a grade 9 and you want to practice those tough grade 8 and 9 questions focused upon those hard and more complex topics which are featured in grade 8 and 9 exam questions. I hope you find the film useful. You can click the link in the description and download the booklet, and then you can work your way through the 10 questions and then watch the film, or you can work on the questions as you watch the film and work alongside me. Now, if you have found these questions useful, you might want to click on the link in the description and download all 50 of my grade 8 and 9 IGCSE exam questions. You can download the booklet, and within the booklet there are links to the solution films for all 50 of those grade 8 and 9 exam questions. Up to you. Right, enough from me. I'll leave you to get on with the maths. Good luck. Question 1. Right, this looks like a question about upper and lower bounds. Let's have a look. Right, we've got a formula for P, and then we're given A, C, and D, each one correct to a different degree of accuracy, and we're being asked to work out the upper bound for the value of P and to give our answer to 2 decimal places. Right, well, generally, with a question like this, before you do any more thinking, simply work out the upper and the lower bound of each of your variables. So A is 58.4, and that's correct to 3 significant figures. So my upper bound is going to be 58.45, and my lower bound, 58.35. Let's have a look at C. Now, C is 20, correct to 2 significant figures. So I'm going to go 20.5 and 19.5. And then I've got D, which is 3.6, correct to 2 significant figures. So 3.65 and 3.55. And now let's write down this formula for P. P is 2 times A minus C, all divided by D. Now I want the upper bound for P. So I'm going to put a up arrow there. Now if I want the upper bound, then I'm going to want the numerator here to be as high as possible. So I want the highest possible A's, and I want to subtract away the lowest possible C. And that will make the numerator as high as possible. And if I want the highest possible P, then I want to divide by the lowest possible number. So I'm going to choose the lowest possible D, because if I divide by a lower number, I get a higher answer. So that is what I'm going to need to substitute in here. Twice times the highest possible A, subtract the lowest possible C, all divided by the lowest possible D. Okay, so I'm going to put that in my calculator. I'm going to use the fraction function, 2 times 58.45 minus 19.5 and divide it by 3.55. Right, that gives me 27.4366 and so on. And I'm asked for the answer to 2 decimal places, so 27.44. And that is question 1. Question 2. Right, this looks like it's going to be a question involving circle theorems. And straight away I can see I've got a quadrilateral there, so I'm thinking about opposite angles in a cyclic quadrilateral, adding to 180. I've also got a tangent here, so I'm thinking about the alternate segment theorem as well, and I'm also thinking about the angle between a tangent and a radius equaling 90 degrees. Let's have a look. A, B, C, and D are points on a circle. Okay, that's how it looks on the diagram. TDV is a tangent. Yes, I clicked that. AB equals AD. Let's have a look. Oh, AB, that line, equals that line. Okay, so I've got the makings of an isosceles triangle, perhaps. Right, angle ADT is 90. Yep, is 71. Yes, that's marked. Work out the size of angle BCD. Right, this angle BCD, that is my target angle there. Okay. All right. Give a reason for each stage of your working. All right. Well, I've got the tangent there, haven't I? So if I were to draw a line from B to D, then I could use the alternate segment theorem. Look, that angle and that angle would be equal, wouldn't they? So my first piece of working is going to be that ABD equals 71, and I shall say alternate segment theorem. Okay, now that angle there then is 71. Right, so that means that this angle is also 71 because, of course, that's an isosceles triangle. So I'm going to say BDA equals 71 equals ABD isos triangle. Now, I can work out this top angle now. That angle there, can't I? Because that's angle DAB. That's going to be 180 minus the 71 minus the 71, because there are 180 degrees in a triangle. So that gives me 38 for that. And now I think I can find my target angle, which is BCD, because I've got 38 here and my target angle, and I know that opposite angles in a cyclic quadrilateral add to 180. So it's going to be 180 minus 38, 142. I could say opposite angles, cyclic quadrilateral, add to 180. And there is one of the possible ways of doing question 2. And BCD is 142 degrees. Question 3. Right, let's look at 3a first. I've got to simplify this algebraic fraction here. Now, first of all, I see it's the power of minus a quarter. So the first thing I'm going to do is I'm going to flip the fraction over, and now it will simply be to the power of a quarter. So that's made things simpler already. Now that's going to be the fourth root, isn't it, to the power of a quarter. So I'm going to need to have the fourth root of y to the 8 and the fourth root of 256 x to the power of 20. So when I'm finding the fourth root of y to the 8, I need to think about something times something times something times something is y to the 8. Well, that's going to be y squared. You divide the power by 4, don't you? Now here I've got the fourth root of 256. What times what times what times what is 256? Answer 4. And then what times what times what times what is x to the power of 20. We'll divide the power by 4, x to the power of 5. So that is part A. Now let's go on to part B. Right, we're subtracting fractions here, aren't we? Algebraic fractions. Now, before we get started, let's write these fractions in a somewhat simpler form. You see on the bottom there, I've got 9x squared minus 25. Well, that's the difference of two squares, because 9x is 3x squared and 25 is 5 squared. So that can be written as 1 over 3x plus 5, 3x minus 5. And let's have a look at this. Can I factorise the bottom there? Yes, I can. I can take a 2 out. Leaves me with 3x plus 5. Right. Now, if I'm going to subtract these fractions, then I need to be working with a common denominator. Let's have a think about the lowest common denominator I could be dealing with. Well, the lowest common denominator is going to be 2 lots of 3x plus 5 times by 3x minus 5. Now, let's look at this first fraction here. What's this denominator being multiplied by to get my new denominator? Answer, it's being multiplied by 2, so I must do the same to the top. 1 times 2 is 2. Minus Now, let's look at this second fraction. What's this denominator been multiplied by to get my new denominator? Answer, it's been multiplied by 3x minus 5, so I must do the same to the top. 1 times 3x minus 5 is 3x minus 5. Now be careful to put that in a bracket, because this minus sign here is going to have an effect on both the 3x and the minus 5. So what I'm going to have is I'm going to have 2 minus 3x plus 5 all over 2 lots of 3x plus 5, 3x minus 5. So that is going to be 7 minus 3x over 2 lots of 3x plus 5 and 3x minus 5. Now, yes, you could multiply out those brackets on the denominator, but you don't need to. You'll get full marks for that answer there. And that is question 3 sorted. Question 4, right, this is a question on coordinate geometry, and it needs a bit of a think about before you dive in, I would suggest. Let's have a look. We're given the equation for line L, and we're told some facts about line M. It goes through the point A, and it goes through the point B, and look at this. L and M are perpendicular to each other. Work out the value of K. So I've got to work out the value of K. It would be useful, wouldn't it, to work out the value of K if I knew the equation of line M. If I could find the equation of M, then I can easily find the value of K, because it's the y coordinate when x is minus 4. So I really need to find out the equation of M. Now, to find out the equation of a line, I need to know 2 things. I need to know a point on the line, and I need to know the gradient of the line. The equation of the line M is what I'm after. Do I know a point on the line M? Yes, I do. It goes through the point A, 5, 6. Do I know the gradient of the line M? Well, I don't, but I do know that the line M is perpendicular to L. So do I know the gradient of L? Well, I know the equation of L is 4y minus 6x equals 33. So if I rearrange that to make y the subject, then I'll be able to read off what the gradient is, because if y is the subject, then the gradient is simply the coefficient of x. So the gradient here is simply 3 over 2, look. So the gradient of L is 3 over 2. So the gradient of M, if M is perpendicular to L, the gradient of M will be the negative reciprocal. Look at that, minus 2/3. So I do know the gradient of M, and I do know a point on the line M. So now I can work out the equation of M. Equation of M. Right, I know it's going to be y equals mx plus c, and I know that little m there is the gradient, so it's going to be y equals minus 2/3 x plus c. And now I use the fact that I know that a point on the line is 5, 6. So I know that when x is 5, y has to be 6. So 6 has to equal 2/3 times 5 plus c. And that will enable me to find out what c is. Let's multiply everything by 3. So I get 18 equals minus 10 plus 3c. So I get 3c equals 28. So I get c equals 28 over 3. So now I know the equation of m is y equals minus 2/3 x plus 28 over 3. Now, what was the question? The question was, find k. And k is the y coordinate when x is minus 4. So let's put x as minus 4 in here, shall we? X equals minus 4. And let's use the equation of the line to find out what y would be. It's going to be minus 2 times minus 4 over 3 plus 28 over 3. So that's minus 8 over 3 plus 28. Sorry, it's plus 8 over 3. Minus 2 times minus 4 is plus 8 plus 28 over 3. So it's 36 over 3. It's 12. So when x is minus 4, y is 12. And to answer the question, k equals 12. So that was quite an involved question 4 there. It required us to find the equation of m and to use that to answer the question. And to find the equation of m, we need to know a point on the line m and also the gradient of the line m. And to find the gradient of the line m, we have to use the fact that it was perpendicular to the line L. Question 5. Right, let's have a look at this diagram first, and let's agree that we're likely to use the intersecting chord theorem. Okay, and now let's have a look. A, D, B, and E are points on the circle. Yes, they're labelled. A, F, B, C, O, E, C, and O, F, D are straight lines. Yes, they look like it. AF is 7, that's marked. FB is 4, that's marked. BC is 5, that's marked. FD is 2, that's marked. And CE is X, that's marked. Find the value of X. Show you're working clearly. Okay, right now. If we're going to use the intersecting chord theorem, we're obviously eventually going to use this line here and this line here. We're probably eventually going to use those intersecting chords, aren't we? Okay. And I notice the intersection is outside the circle, so that's quite fun. But before we do that, we're going to need to find out more side lengths, because before I use this chord here, I could really do with knowing the radius of the circle, these two lengths, or the diameter of the circle. So let's just go back a second and let's have a think about this chord here. Okay. All I know about that so far is that part of it is 2, and then the other part is the rest of the diameter of the circle. Let's call this point Z, just so we've got some way of referencing it. So if I think about DZ, now I could think about DZ alongside, alongside what? Well, I could think about it alongside AB. Look, there are 2 intersecting chords, and I know the lengths I need for AB. So let's set up that equation there, shall we? So I'm going to have AB and DZ. And I've got F and F and F and F multiplied and multiplied. So there's the intersecting chord theorem formula set up. Right, AF is 7 times BF is 4 equals DF is 2 and ZF, I don't know what that is, I'll just call it ZF. But look, I can find ZF now. 28 equals 2 times ZF. So ZF is 14. Right, so all the way from here to here is 14, which means that the whole of the diameter is 16. So I know the diameter of the circle is 16, the 14 plus this 2 here. So that means I now know the radius is 8. Now I think I'm in a position to use this intersecting chord here. These 2 intersecting chords here. I think I'm in a position to use that one because I know that this is 8 and that's 8 and that's X. And I think I can combine that one with AC, with this one. I'll draw it in blue. AC, right. So this time I have got chords as follows. I've got chord AB, and I've got chord, I haven't given this one a name, I'll call it Y. And I've got chord YD. E. And they intersect at the point C. C, 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 multiply, multiply. Right. Now, can I fill in the gaps here? Let's have a think. So A to C is 7 plus 4 plus 5, 16. Times B to C is 5 equals Y to C. Well, Y to C is 8 and 8 and x, isn't it? So that's 16 plus x multiplied by EC is x. Look at this. I think I'm going to get a quadratic equation. Let's have a look. So I've got 80 equals 16x plus x squared. So I've got x squared plus 16x minus 80 equals 0. So can I factorise this? I think I can. Let's have a look. Got to multiply to 80 and add to 16. 20 and 4 maybe, because one of them's plus, one of them's minus. Let's have a look. 20 and 4 plus 20 minus 4. That's going to give me minus 80 and it gives me plus 16. So look at that. My solutions are x is 4 or minus 20. So are there two answers then for x? Let's have a look at the diagram. Does it make sense for x to be negative 20? It doesn't. X is clearly a positive value. So x is minus 20 is not valid, meaning that the answer is that x is 4. So in question 5 there, we use the intersecting chord theorem twice. Once where the chords intersected within the circle at the point F, and on the second occasion where the chords intersected outside the circle at the point C. Question 6. Now, looking at the diagram here, I think we're going to be dealing with circle theorems. Okay, we're told that A, B, C, and D are points on the circle. That's how it's drawn. We've got a tangent to the circle. And look at that. We've got AB equaling CB. So we've got the makings of an isosceles triangle there, haven't we? Okay, let's draw this point here. Okay, now, now I've drawn that, I can see we might be dealing with alternate segment theorem as well. Right, angle BCQ is x, that's labelled already. Prove that angle CDA, that's this angle here, so that is our target. And we have to prove that that equals 2x. Let's have a look. Well, the first thing I reckon is that I can find this angle here, angle CAB. Well, that's x because of the alternate segment theorem. Okay, and now, therefore, this angle here is also going to be x, right? Because that's an isosceles triangle. So ACB equals x because ABC is isos. So that means that this angle here, ABC, is going to be 180 minus 2x, isn't it? Okay. Oh, now just a minute. You know how opposite angles in a cyclic quadrilateral have to add to 180? That means that this angle and this angle must add to 180. So ABC plus CDA have to equal 180. Opposite angles in a cyclic quadrilateral. I'll leave you to write that out in full hand. So ABC is 180 minus 2x plus CDA has to equal 180. Well, therefore, CDA must equal 2x. There you are. Bob's your uncle. It's done. Prove that CDA is 2x. Give reasons for each stage of your working. That's question 6. Finished. Question 7. Looks like we're dealing with surds here. Show that the left-hand side equals the right-hand side. Show each stage of your working. Well, let's take this left-hand side then, and let's simplify it and see if we can't get the right-hand side as our answer. Okay, right, now, to start with, let's write that like this, and then expand the brackets. See what happens. So 6 sixes are 36, plus 6 times 2 root 12 is 12 root 12, plus 2 root 12 times 6 is 12 root 12, plus, and now I'm doing this, 2 root 12 times 2 root 12. Well, that's 4 times root 12 times root 12. Root 12 times root 12 is 12, so that's just 4 12s, 48. So now let's simplify this. Shall we? I've got 36 and 48, that's 70, 84, plus 24 root 12. Right. Well, I'm trying to get it equal to this, aren't I? So I suppose I could pull out a 12, because I can do 12 into 84, can't I, goes 7 times, and 12 into 24 root 12 goes 2 root 12. I'm almost there now. I've got the 12 outside, I've got the 7, it's just this bit. How am I going to get that? Aha, wait a second, I can simplify this root 12. Okay, let me show you how, in case you're not there already. It's going to be 7 plus, now 2 times, or root 12 is 4 times 3. And so you can write that as 12 lots of 7 plus. Now you can take that 4 out of the square root and square root it. So it ends up as a 2. So outside the square root, you'll have 2 times 2 is 4. And inside the square root, you'll have just 3. So there you go. I have shown that the left-hand side is equal to the right-hand side. Okay, let's have a look at part B. All right, I've got an algebraic fraction here, and the first thing I notice, it's to a negative power. So I'm going to write down the reciprocal of that fraction. I'm going to flip it over, and now that is to a positive power. Okay, now I'm going to think about this as being t to the 15 to the power of 2/3 over 27a to the 12 raised to the power of 2/3. Now, if I look at the top there, when you've got something to the power of 15 and you raise that to the power of 2/3, then you simply end up with t to the power of 15 times 2/3. Those are your rules of indices, aren't they? And 15 times 2/3 is 10. So the top is simply t to the power of 10. Now the denominator, the bottom here, I've got 27 here to the power of 2/3. Well, that's going to be the cube root of 27 squared. So the cube root of 27 is 3, and if I square that, I get 9. So that was, let me write that down in case it makes it easier, the cube root of 27 squared. So the cube root of 27 is 3, square it, you get 9. Now what about this a to the 12 raised to the power of 2/3? Well, I'll just use my rules of indices again. And so it's going to be a to the power of 2 times 2/3, which is a to the power of 8. So there is my solution to part B. And I'm just having a quick look to see if I can do any more simplification, because sometimes they have a common denominator, common factor top and bottom, but they don't in this case. So that is question number 7 complete. Question 8. Okay, I've got the sector of a circle OAB, and O is the centre of the circle, and that's an angle of x at the top there. And this sector is curved around so that OA meets OB, and it forms the curved surface of a cone. There you go. Now I'm told the height of the cone, and I'm also told the volume of the cone. Work out the value of x. Well, let's start out by using that fact we've been given about the volume of the cone. Now, the volume of the cone is 1600 cubic centimetres, and the formula for the volume of the cone is 1/3 pi r squared h, and I know that h is 25. So that means that I have this equation to solve for r. So I'm going to do 1600 times by 3 equals, divide by 25 equals, and so I get 192, and I'll divide by pi, and that is r squared. So r is the square root of 192 over pi. Right, so that means that I know that length there, which means that I can find the length from O to A by using Pythagoras. Let's call that y for a moment. Okay, right, so y squared is going to be it's going to be r squared, which is 192 over pi, square rooted, squared, plus 25 squared. So all I have to do on my calculator is 192 divided by pi equals, add on 25 squared equals, and square root my answer. And that tells me that y is 26.1938, dot, dot, dot. So that is the length from O to A, which is also the length from O to A and O to B on this diagram up the top. Ah, that's interesting, because now I can find an expression for this curved part of the circumference there, and also I know that that length from A to B is the same as this length from A to B. All on this bottom diagram here, it's the same as the circumference of that circle. So let's start with the circumference of that circle. C equals pi d. So the circumference is going to be pi times twice r, isn't it? So pi times 2 times the square root of 192 over pi. Well, I could obviously put a number on that if I wanted to. Let's do that, shall we? So it's going to be 192 divided by pi equals square root answer equals times by 2 equals times by pi equals 49.11968 and so on. And I know, therefore, using this diagram here, that that curved blue part of the circumference also has a length of 49.11968 and so on, and I know that equals x 360ths of pi times the diameter, where the diameter is twice that 26, isn't it? Pi times 2 times 26.1938. So I suspect that I've ended up with a formula here, an equation here I can solve for x. So I've got the 49.11968 on my calculator already, so times that by 360, divide it by 2, and divide it by 26.1938. Okay, and divide it by pi. Gives me x equals 107.443 and so on. I'm asked for the answer. Find x, give your answer correct to the nearest whole number. 107 centimetres is my answer for x. And that's question 8 done. Question 9. A frustum is made by removing a small cone from a large cone. The cones are mathematically similar. Okay, I'm just looking at the picture here and taking it on board. The large cone has a base radius of r and a height h, that's mentioned there. Given that the volume of the frustum is 98/125ths of the volume of the large cone. Well, it's all very well looking at the volume of the frustum as a ratio of the volume of the large cone, or as a fraction of the volume of the large cone. But the frustum and the large cone aren't similar, are they? It'd be much more pertinent to look at the volume of the cone that's being cut off and the volume of the large cone. You see, if the volume of the frustum here, if that bit is 98/125ths, then the volume of that small cone on the top there must be the remainder, 27/125ths. So, if I were to think about the volume here, and let's take the large cone and the small cone, the one I've cut off, then I would multiply by 27/125ths there. to go from volume of the large to volume of the small. So that means that if I was dealing with linear lengths, the scale factor would be the cube root, wouldn't it? So the cube root of 27 is 3, the cube root of 125 is 5. So if I was dealing with lengths, I'd be multiplying by 3/5, and if I was dealing with areas, I'd be multiplying by the square of that 9/25. Okay, now let's just go back to the question. Find an expression in terms of h for the height of the frustum. Well, I can find an expression in terms of h for the height of the small cone. The height of the large cone is h, so the height of the small cone is 3/5 of h. Okay, so this height here is 3/5 of h, which means that the height of the frustum must be the remainder, 2/5 of h. Okay, so height of frustum equals 2/5 of h. And that was seemingly quite a complicated question until we broke it down into scale factors. Question 10. A solid is made from a hemisphere and a cylinder. Yep, I'm just looking at that. I've got the cylinder here, and there's the hemisphere, the half a sphere on the top. The plane face of the hemisphere coincides with the upper plane face of the cylinder. Yes, that's as it's drawn. The hemisphere and the cylinder have the same radius. Yep, that's as drawn. The ratio of the radius of the cylinder to the height of the cylinder is 1 to 3. So wait a minute. So if this is r here, then the height of the cylinder, not the height of the whole solid, the height of the cylinder must be 3r. Okay. Given that the solid has a volume of that, okay, well, let's write an expression for the volume of the solid, shall we? So, the volume of the solid, well, the volume of the solid will have the volume of the cylinder, well, the volume of the cylinder is pi r squared h, plus the volume of the hemisphere. Well, the volume of a whole sphere is 4/3 pi r cubed. We've only got half of it here, so I'll multiply that by half. So there's an expression for the volume of the whole solid, and I know that that equals 792 pi. Now, that h, I can do without that because I know that h is 3 times r. So what I've actually got here is pi r squared times 3r plus, now 4/3 times a half, that's 4/6, pi r cubed equals 792 pi. Let's carry on. 3 pi r cubed plus 2/3 of pi r cubed is 792 pi. Let's divide everything by pi. 3r cubed plus 2/3 r cubed equals 792. Look at that. So 3 and 2/3 of r cubed is 792. Divide both sides by 3 and 2/3. R cubed is 216. Cube root both sides. R is 6. Right. Now I found the radius is 6. Now, easy to make a mistake now. Do you see here that it says work out the height of the solid? Now, the height of the solid is this length here. It's from the top of the solid to the bottom. So it includes up to here, which is 3r, and then that bit there, which is the radius in the hemisphere, isn't it? Another r. So the height of the whole solid is 4r. So 4 times 6, 24 centimetres. And that is question 10 done. Hi, well done for working your way through those 10 tough questions. Now, if you are aiming to get a top grade, a grade 8 or 9 on your Edexcel IGCSE Maths, I would urge you to click on the link in the description and download the whole booklet so you can tackle all 50 of my grade 8 and 9 IGCSE Maths exam questions. Download the whole booklet. It comes with links to all the video solutions. Alternatively, there are some other resources to help you, or each targeted at you if you are aiming for that top grade. Look in the description of this film and have a look at the links. Thanks for watching. See you in the next film.